Welcome to the Explainer. Ever wonder how an app goes from just a random idea to something real, something you can actually use? Well, today we're cracking open an engineer's notebook to do just that. We're going to follow the journey of a modern app, from a simple thought all the way to a full-stack AI-powered solution. So here's our game plan. We'll start with a task, what's the problem, then the principle, how do we solve it. After that, we'll look at the blueprint for the solution, see the implementation in action, and wrap up with a big takeaway. Okay, first up, the task. In the original notebook, it's called Zadacha. This is all about nailing down the exact problem we're setting out to fix. So let me ask you this. Have you ever been in another country, someone tells you a price or a phone number, and your brain just freezes for a second? It's like this little mental glitch, a hiccup, where you're just buffering. What's going on there? Well, it turns out that just knowing the numbers isn't the real goal. That's step one. The real prize is what's called automaticity. It's about making it a reflex, processing those numbers without even thinking about it. Okay, this diagram really breaks it down. Look at path A. That's a native speaker. The sound goes in and boom, instant understanding. Simple. But now, check out path B. This is the rest of us. We hear the number, and our brain hits this translation buffer. We're mentally converting 70 into the digits 70 before we can process it. And that little step, it adds a delay of over 1,500 milliseconds, a second and a half. In a real conversation, that's an eternity. It's basically a communication breakdown. So we've got the problem. Now for the next section from the notebook, the principle, or princip. How can we use actual science to fix this mental glitch? Our whole understanding of memory has been this incredible journey. It all started way back in 1885 with a guy named Hermann Ebbinghaus and his discovery of the forgetting curve, that thing where we just naturally forget stuff over time. Then in the 70s, we got physical solutions like flashcard boxes. Fast forward to 1987, and we get the game-changing super memo algorithm for computers. And now we're in the age of AI, where models can literally predict how likely you are to remember something. It's wild. And here's the key takeaway from all that science. Real learning, the kind that sticks, has to be a bit of a struggle. It's not about just passively reading a book. No, it's that active effort, that mental sweat of trying to recall something that actually builds and strengthens the connections in your brain. Okay, problem defined, science understood. Now for the fun part, the blueprint, or schema. Let's see how we turn all this theory into an actual engineering plan. This is where things get really interesting, because a number isn't just a number, right? Think about it. The way you say a year is different from how you say a price. The app has to understand these different modalities. Integers, time, currency, dates. Each one has its own set of rules, just like our brains handle them differently. Context is king here. You'd say the year 1990, but you'd say the price is $19.90. Totally different. The system has to get that right. Just treating all numbers the same, that's a total novice mistake, and it just wouldn't work. Okay, the blueprint's done. Time for realizacja, implementation. Let's see how all this planning actually looks in the final app. And here it is. Check it out. On the left, you see that grid of green squares. That's not just some pretty design. That's the spaced repetition algorithm in action, literally showing you how your memory is strengthening over time. And on the right, in the settings, you can see how you can really dial it in for yourself, even getting the AI to check your pronunciation. Super cool. So, what's under the hood? Well, it's built with Flutter, which is awesome because you write the code once and it runs on both iPhones and Android phones. Super efficient. And for the really brainy stuff, like scoring your pronunciation, it's all powered by Azure AI services on the back end. That's where the magic happens. All right, we're at the final and maybe the most important part of the whole journey, itogi, or the conclusion. What was the big lesson learned from all this? And here it is, the big piece of advice from the engineer's notebook. Don't fix the code, fix the spec. Think of it like building a house. You wouldn't just start throwing up walls and then try to fix the crooked foundation later, right? It's way, way better to get the blueprint, the specification, perfect from the start, rather than trying to clean up a mess later on. What's so cool about this project is how it mashes up brain science with cutting-edge AI, and it really makes you wonder, what's next? As AI becomes just another tool in the box for developers, what other human abilities could we start to enhance or unlock? What new skills could we learn when we team up human brains and artificial ones? Hey, thanks so much for walking through this with me. If you want to dive deeper into the Numbers Gym project, just scan the code on your screen. Thanks for watching.